So evolving role of geospatial industry has led to market growth. Many, as I discussed earlier, many emerging roles have arisen after development of technology, which are currently arising the market, driving the market, like increasing sensor data, fusion capability, increasing digitization, workflow integration, geospatial industry transition is offering a lot of entrepreneurship opportunities as well. So other than, there are a lot of opportunities in government and public sectors. One can work in various government agencies. They can work as a geospatial analyst or researcher in government agencies responsible for making maps, land use planning, theme-specific data creation and analytics, as well as they can work in the urban planning and development. They can work as an environmental manager in the transportation sector, in the disaster management and emergency service, and agriculture and rural development. So there are various program of the government schemes where the professionals in geospatial expertise can work, which is Digital India, Smart City and Amrut Cities scheme of government, National Mission for Clean Ganga, interlinking of rivers, Northeastern Regional Urban Government Development Program, and there is one more, Delhi-Mumbai Industrial Corridor projects. So this slide shows you the list of various agencies in government where one can work. And I request you to please keep exploring their website because from time to time they advertise a lot of position at various capabilities. So don't have to like write anything. I will request Dr. Ramia to share this presentation so that you can use it for later. Other than there are a lot of skilling courses offered by many government organizations. One is that course is offered by NIGST Survey of India. So you can also, there are short-term courses, long-term courses. So again, you can check their websites, and along with the PhD also, you can like add value by utilizing these various courses. I will not just go through the details. Similarly, there's a BIS, which is a Bureau of Indian Standards. What BIS does, they develop various standards. And in geospatial domain, they have a specialized committee, LITD 2022. So they also, I think Dr. Harsha is also there from like, yeah, part of it. So like from time to time, they advertise a lot of position for scientists and analysts, market analysts, etc. So you can check their website and you can get the very good opportunity. And as you already know, there are a lot of opportunities in the academia sector also. You can, after the PhD, you can go for professorship, research scientist, as an advisor and consultant. And you can also join various postdoctoral positions offered in various universities. So this also telling you the same thing, that various positions one can get after doing the PhD or postdoc. As GIS consultant, you can become a GIS manager. You can become a remote sensing analyst, GIS engineer, GIS experts. So only like I'm telling you, there now the opportunities are enormous. So one has to just come out from their comfort zone and search for it. And we are from DST, we are there for any kind of handholding if you require. And as you know, the DST supports a lot of extramural funding also. So in that, we like advertise a lot of position as a research scientist. So in that also one can work. So similar in non-governmental organization and international organization also, you can work. We also support a lot of NGOs for creating local level solutions. So you can work with them and get a ground level solution for the society. So you can, from working in the NGO, you can directly see the impact of your work. So from the right side of the table, there are a lot of international organizations also. who are advertise a lot of position related to geospatial domain. So you can explore and get the opportunity as well. So similar way in the private sector, in the industry, there are again a lot of career opportunities are there. One can have this GIS software development, can become a geospatial, can work for a geospatial consulting firms, data analytics and data science, can become an environmental consultant, telecommunication also they can work for, and nevertheless, remote sensing and satellite imagery analysis, for that also they can work. So this is also the same thing I told you about. This is the list of companies in India who are working in this domain. So you can be in touch with them and get a suitable opportunity as per your expertise. And as I told you, there are like two ways. One is the like comfort zone you are working, and you can get the, the regular positions, scientist, professorship, lecturer and all. The other way is to like work, you become a startup or entrepreneur, because from the government side, there are a lot of funding opportunities for startups who are providing the ground level solution. From DST side also, we support the startups because we have a lot of TIH, Technology Innovation Hub, across the country, and we support the startups. So in this way also, there are some details of the various startups and incubator centers. Various IITs, they have established incubator centers where you can work. Same is like details of the various program where entrepreneurs can get a job. You can work as an entrepreneur by identified by various ministries and departments. So now the DST's capacity building program. So basically this, our division, which is now National Geospatial Program Division, it was initiated in 1982. And that time it was called NRDMS. So since its inception, it has showed proof of technology and application for the local level planning. But as per the changing requirement worldwide, now it has been evolved as a National Geospatial Program Division to catalyze the national geospatial ecosystem in the country. So basically, we are promoting all verticals of geospatial science, geospatial technology, solution, enterprise, capacity building, and international cooperation. And from time to time, we are issuing call for proposal in the relevant domains. So today we are going to talk about our capacity building program. So our capacity building program in DST, it started almost a decade back. So currently there are 3 levels of the capacity building that we offer. One is 21 days level 1, which is summer winter school of 3 weeks. So basically this is a 3-week program. It focuses on the basics of the geospatial science and technology. And along with that, this program also contains a hands-on approach using open software. So from this cycle, we have started a new initiative under this. Is basically for promotion of spatial thinking at the early stage. The other program, which is also 21 days, level 2, this is an advanced course, 3 weeks program again. It focuses on building capacities among the participants by deepening their knowledge and competencies about various specialization and advanced aspects of geospatial technologies, again using the open software, source software only. The other initiative that we started in the last cycle is 3 days Geo Innovation Challenge. So where this program is designed only for the young professional below 40 years of age. So this is 3 days program. So the objective of this 3 days innovation challenge is to recognize, encourage, and nurture innovation for national socio-economic development processes. So what we do, we invite the problem statements from the young professionals, and from DST side, we are emphasizing that we'll use those problem statements as a call for proposal. So list of those problem statement we'll publish on our website. So this slide shows how this program has been evolved as we talk about. So from last 1 decade, it has trained more than 5,000 participants and it's still growing. And we are keep adding new gaps to fill the gaps. Level 1 program, they are standardized modules. And as per the requirement and as per the emerging technology, we are keep adding new modules, like in the geodesy, international policy, and BIM, AI, ML, etc. So this is our DST portal. It's called DST IGAT portal. This is the one-stop resource for learning and teaching. So as I told you, this portal has lots of standardized modules, a lot of data also. So a lot of tutorials also. So I request you that you please go through this and keep checking. And lot of information about our capacity building program is there. And how we are changing and when we are advertising, all the information is there. So other than the other initiatives of National Geospatial Program Division is, as I told you, we should call for proposals for geospatial science, technology, and solution and capacity building also. So upcoming initiative is this. I mean, in one month or so, we are planning to invite call for proposal in consortium mode, where the problem statements identified by the stakeholders or user agencies will be solved by the academia in consortium with startup and industry. So you can also join in that. Other important initiative that was taken is we are planning to establish a geospatial innovation hub at Hyderabad in the Survey of India building. So MOU has been already signed between the DST, NIGST Survey of India and IIT Tirupati Navishkar. They also have an innovation hub. So this center of excellence, it's envisaged that it will cater to the emerging technology solution requirement of the geospatial domain. It will also provide the availability of incubator facilities, also mentorship programs, networking opportunities, as well as a lot of capacity building opportunities. Our initiative is we have established a JICE hub at IIT Bombay. So they also offer many training programs. They offer summer winter school for standardization, data modeling, open source geospatial technologies and all. So if you also keep checking their website and you will get the information about the various training programs so that you can also upskill your current status. Again, we have also established a National Center of Geodesy at IIT Kanpur. So similar way, they also organize many training programs in geodesy, dedicated to geodesy. There are very few experts in geodesy who are working in our country. So it will be very good if you can get trained in this domain as well. And if you get trained in geodesy, there are a lot of opportunities from government sector. So with this, I hope I have, I tried to collect a lot of opportunities which can have for student like you, for PhD, after PhD. And let me tell you, the scenario has changed enormously. Because after the policy, there are a lot of demand for geospatial experts, especially at the top level. I mean, at the base level, we can get sufficient people, but at the higher level, there's a lot of scarcity. So from DST, I urge you that you please, any help if you need, please try to contact me. My details are here. And I will request Dr. Ramya to, if you can share this presentation. Thank you.
A very good afternoon, everyone. Myself is Rahisha. I'm a PhD scholar here. And I would thank to all the DC committee members for giving an opportunity for presenting my work here. And here I am presenting a small part of my research. The title is An Integrated Land Use, Transportation, Event-Triggered Urban Growth Model. By title itself, you may identify that because my major problem will be more into urbanization problems. And what is exactly urbanization? Urbanization, we know that people are living, like moving towards city side rather than the rural side. From the picture, you can identify that 1970s, what was the scenario? You can see a lot of blue side, right? Blue areas. But in 1950s or after 2050 or 2030s, the condition will be look like this based on an UN projections or a prediction system. They are telling that major Asian system, all the country, like major part of the world will be urbanized. And what is, like, if urbanization is happening like this, we have a lot of positive impacts also, right? Like we have a positive like golden opportunity for employment opportunity, health issue, health beneficiaries or educational system. A lot of positive impacts are there, economic sector as well. But we have to think about negative problems also, like a negative impact of urbanization. So what we can do for that? What we can do, we have to make a sustainable urban planning, because whatever we are feeling now, it should be sustainable for a future generation as well. So when you see an urban system, it is not a small, it's not a simple word. We cannot explain an urban system. It's a very, very complicated system. It is involved with a lot of urban environmental problems or even climate, weather. So you can see population, demographic studies. What I want to highlight here, within the urban studies or urban informatics, we have a lot of sectors. Within each sector, we have a lot of opportunities for a research to make India more sustainable. Not even India, like developing countries, we have to make it a more sustainable way. Okay? With that, this is what my motivation, what I can do it with my knowledge, or what I can help in this like field. Okay? Then we know that metropolitan cities are emerging like anything. And what is next is that small and medium-sized cities should be, we have to focus on those cities, not only metropolitan cities. We have to give enough infrastructure to these kind of cities as well. Okay? Not only infrastructure, what are the benefits, like how the citizens should get a benefit from, if they are sitting, they are staying in a medium-sized cities also, they should be equally benefited as how the metropolitan cities are giving. Okay? So with that, as a geospatial scientist or as geospatial student, we know that 1980s onwards, a lot of studies are happening by using remote sensing satellite imageries. Because satellite imageries are available from 1970s onwards, we can utilize those satellite imageries, and we can use, generate land use, land cover mapping. This is actually overlooked problem or overlooked research. We can create LULC, and we can study only urban problems or only water resource problem or a vegetation problem, agriculture problem. There are a lot of opportunities are there within a LULC system. Then my major focus is on urban system. Here, first I have created LULC. Okay, I have created LULC. That is a base map for whatever analysis what we can further do it. So my second the target was concentrate on urban part. What is happening in urban area? How it is expanding over a time, and what is next? How can we visualize futures? The same area, how it will be in the next 5 years or next 10 years, how it looks. So that we call it as urban modeling. Okay? Why we are doing all this analysis or all this modeling and all? We have to look into sustainable urban development scenarios. Okay? With that in my mind, I have framed few objectives for my research. First, understanding the spatio-temporal analysis and understanding how it is evolved over a period. Then nobody has looked into event-triggered model. If some event happened in particular cities, how that area has changed. Okay, even in the sense, for me, event is a construction of a building or even an airport or a metro station or a railway network or a bridges. If such event happened in such cities, how the neighborhood area has changed. So that is an important, I didn't see many papers. I saw some papers regarding event triggered based on they are preparing some kind of Olympics or some kind of like sports activities in that. Because of that, how economic sector has evolved. These kind of papers I had a chance to read. So from that, I got some idea that how the event-triggered urban growth can be analyzed. Then, by using the latest technology, model it and see how future looks. Then, okay, identify so many factors, and what is we can do it with transportation. Consider a particular portion as a transportation sector, and how the transportation sector is related to urban settlement. So that is my fourth objective, and developing some integrated model to predict transportation system, because we don't have a road network for a maybe historical road network map. We don't have it. Whatever we have it from OpenStreetMap, that is what we are using it. But settlement map, we can easily map it by using satellite imageries. And is it possible to connect these two systems together? And if we have a settlement map, then easily we can use it, like we can generate it. Is it possible to use those settlement map to predict a transportation system there? Transportation in the sense is simple network density. If you could predict, that is a biggest research gap in this field. Okay, then my study area, it's Bangalore. And here you can see a black boundary. This is the BBMP area. And BBMP area, almost many researchers, many papers has come. They have a lot of research has happened in the Bangalore area, okay, BBMP area. I extended my study area because BBMP or Bangalore city is already, it is urbanized. It is a concrete city now. So what is happening in the neighborhood or a rural area, peri-urban area? So that was my major study area. Okay. Then LULC creation, it's a simple task with 4 classes, level 1 classification. Then I did urban binarization with only urban settlement map. Then I did a grid-wise analysis. This we call it as a micro-level analysis. Each grid, or a 5 by 5 or a 5.6 by 5.6 kilometer, within one grid, how the changes happened. Based on, and study area has taken Bangalore and surrounding, right? And the study period is 1973 to 2023, means last 50 years of research. Okay? Then you can see here, see how the Bangalore area has evolved. 1970s, how it was, a lot of greenery, barren land, and you can see it's completely red colored now. That means Bangalore area has expanded the built up area, and more than like maybe if you are from Bangalore, you can see that the airport area or beyond the boundary of wards, more parts, it's become a built up area. This is a database. This is considered as a base database for my further analysis. So you can see here statistics like how the urban area has grown, how the vegetation has grown, or even you can see before it was only 4%, now it is a 22.29% of built up area. But this is 22, you may feel that 22 is a very less number, right? But the 22 is considering for the entire area, not only BBMB area. If it is BBMB area, it is 92%. Then you can see the statistics. That means overall, from the first research objective, what was the result? That urban area is expanding like anything. Within 1 year or 2 year, 2%, 3% increment is happening. Okay? Then I want to see the expansion map. Within a shorter interval, how the expansion is happening. You can see within a short interval, you can see 1973 to urban area. This red part is 1973 urban area. Within the next few years, the yellow color is a simple expansion map. I want to see how expansion is happening. Then next, because we have a huge database now, generating database, or we don't have a freely available LULC map for frequent years. Okay, so here I could identify that building density, how it is changing over a period within BBMB area. You can see initially 1973, that was the condition. And later it was completely packed with building density. Then you can see the hotspot analysis as well. That means within a year, percentage of change. You can see this area last 20 years. And here you can see not part of the Bangalore has changing. Only 5 minutes left. Huh? I got. Okay. Really sorry. So here, see, expansion is happening like this. So I'll come into the major contribution of my work into this. Event triggered means how the events are happening, and this is the major contribution in the sense, if airport is coming like in this location, how the area has changed. Okay. Then this is then urban growth modeling with the prediction of 2025 and 2030. And we have a lot of modeling models are available. Then next is transportation parameter. I'll just show this result, okay, because objective is already discussed. Then result part you can see here. Central part of the BBMB area have a connectivity is more, but outer peripheral area of BBMB does not have it. So this connectivity issues, transportation, congestion problem, these problem can be analyzed very well. Then we have to concentrate on open source software such as QGIS, GRASS software, whatever Python code are there. Just focus on open source software to do such a biggest analysis in this world. We can contribute a lot of things. See, grid level analysis, which grid network is very less. Okay. Then the major contribution from my research. See, I know that Bangalore is like this, but what is it? We have to look into the neighborhood cities, small and medium-sized cities. I have taken 1918 cities from Karnataka. Then, but to do a modeling, that is not sufficient. We need to get a lot of database. So similar kind of a cities from entire nation I have collected. I just analyzed how the connectivity has changed, identified that which are the smallest city does not have enough connectivity, so that we got the chance to publish it in IGAS. Then we have a lot of technologies within our hand. GAN technology, generate. We can simulate. We can generate small and medium-sized cities if we have a huge database. Then I could generate similar kind of database. And with that, I identify, because we have a 503 database now. We have a road network system. We have a settlement system. I try to correlate both. Then I identify that both have a very good correlation within that. So then I identified that when we have a settlement map, we can know what should be the network density of that area. And our model is called KRR. That model have 0.71. Then, okay, model is ready. Now we have to validate our model. That is the important parameter, right? To validate our model, we have taken some of the other cities which does not included while doing training. That we have taken Mysore, Mangalore, Hubli and all neighborhood Bangalore regions. And we predicted, this is the original road network. Then we have predicted network density of that particular area. And we have calculated actual area as well. And our research is very similar. Like it's almost 1 kilometer per square kilometer difference only. But that is a very good research what we could achieve. And from our research, we could publish many. This is my 11th conference I am attending from my research work. And you can see this paper, journal publication with prediction of transportation index. We could publish it in a Nature Science scientific report. Then that is I feel that is the biggest achievement. And not only the urban studies, we last 2 to 3 years, we have conducted a lot of workshops how to promote these kind of technology for a future, or maybe there are a lot of sustainable development goals we are aiming, right, in 2030. So we have to do, as a researcher or a scholar, we have to do some kind of open source involvement or research more into how it can be beneficial to the society. With that, I conclude. This is my team. Uttam Kumar sir is my professor, and you collaborated with Tanuja Chakrabarti. He is the assistant professor from Sorbonne University. And future scope, because right now, due to the last 4 years, I was looking into the transportation problem. In future, I can look into the environmental parameters, weather, and what is the relationship with settlement. Not only in settlement, by build up, we look into the vegetation part, water resource part. So there are a lot of scopes are there within our research industry. Then with that, I'll conclude. Thank you so much for giving this opportunity. Sir, in our Indian cases, we are not able to get an actual road network. Whatever is there in the OpenStreetMap that I'm making, utilize it. Like, that means some case of a small and medium sized, that database itself is not updated properly. So we have taken 505 similar kind of a cities to identify the relationship between transportation and settlement, but still lack of data, like it's not updated. So that is one limitation within the studies. But still we are getting 1 kilometer, only 1 kilometer difference. When I see the Mysore, it is almost some 10 or something we could get it. Some actual is very similar. 1 kilometer is very like we are taking a smaller area actually, small and medium sized cities. Yes. Yes. Mm-hmm. Yes, sir, I did that because of lack of time. We have used a STM model and plus model, that is the state of art model. Actually, I have done it because when I see the 5 minutes, I was hurried to show by the actual result. Actually, I have done a lot of 5 to 6 modeling part. The best 2 model I have included here, and plus model is there. No, plus model. The problem is that we have maybe time. And here we have used a lot of driving factors. But the problem, we don't have a time series of driving factors here. And here, the another model is spatio-temporal metrics. Here, we need only LULC of a 50 years. That is sufficient. But the problem, driving factors also impact the expansion. But that I'm not considering. There is a like plus and minus of these models are there. If we have a series of driving factors, then we are able to collaborate with the LULC. Then it is very good model with a spatio-temporal model. And it will run very well with our like normal system. We don't want any high computing system as well. It's completely open source. I never used any kind of a professional software or procured software. Future scope is that right now I'm looking into the population of 20,000 to 5 lakhs, like because there is a government project called Integrated Development or Small and Medium Town Scheme. So I want to focus on how the government can focus on funding for transportation expansion. Okay, but the problem is that there are a lot of funding, like it can be fund can be contributed to maybe sewage treatment or some other projects as well. But here I could see that if you give a settlement map, my model can say that what is the network density of that area. Suppose that even the city is giving again they are asking fund for the same project or a road development. The government can take a decision that okay, the city is having enough network density, you should focus on some other problems, not network density, because network density of road network is well developed. So some kind of this we can do. And in future, instead of small and medium, we can develop a like maybe metropolitan city, the scenario or the maybe the this relationship will vary, not the same as a small and medium. I it's randomly choose, but even though I focused on small and medium sized cities only, because I want a similar kind of cities to get it. Thank you so much. Thank you so much.
Good evening, everyone. My name is Shuba Pandey. I'm pursuing PhD under Dr. Salil Goel in IIT Kanpur. So the topic of my presentation is development of a robust 3D point cloud registration algorithm for unstructured and complex environment. So this is the table of content where I'm going to give the brief introduction, then methodology, then result, which I'll discuss in the further slides. So objective of my research is the calibration of multiple velodyne sensor to get the better coverage and better data density. And second objective is the development of a setup which is efficient for the data collection in open environment and as well as the indoor environment. And third objective is the assessment of the different factors which affect the accuracy of the registration algorithm. So, this is the so point cloud registration is basically the method of the alignment or merging of the different point cloud collected from the different position on the orientation of the same environment. It could have collected from the same sensor or the different sensor. So it basically involves the transformation of the different coordinates into common coordinate system using a transformation matrix. So it's very important to do the point cloud registration because it is the initial or the fundamental step of any 3D modeling. So it's important because we have some type of LiDAR which has the limited field of view. So there are so many challenges in doing the point cloud registration. So the first challenge is in the environment itself. So wherever we are collecting the data, that is the one of the important factor. For example, if we are collecting the data set in a complex forest plot where it's very difficult to find the matching feature and using which we do the registration. Conversely, if we are doing the data collection in an environment like closed build-up area like this room, so it has a very planar or linear feature, orthogonal linear feature, then the point cloud registration will be very easy and the accuracy will be higher. And second is the data sparsity. For example, if there is some sensor which gives some noisy kind of data, or it has the poor data density, then also it will create a problem for the point cloud registration. And third is the algorithm selection. It is one of the very important factors which affect the accuracy of the point cloud registration. For example, since there is not a single algorithm has been developed which can be utilized for any kind of environmental site. So if there is an algorithm which is developed for a specific area like built up land or enclosed environment, then that algorithm cannot be implemented for some complex or unstructured kind of environment like forest. Hence, selection of algorithm is very important in doing the point cloud registration. And fourth is the matching feature. So the basic fundamental step of the registration algorithm is the finding the matching feature. That is also important. Also, if in case if you are not able to find the good matching feature, then registration, then the accuracy will be hampered. So there are so many applications of the point cloud registration. So first is automatic updation of the 3D building. It is applicable for the calibration also, geospatial mapping or the autonomous vehicle or some application in the robotics as well. Sorry, here I didn't explain the figure. So there are three objects whose 2-point cloud has been shown. One is shown in yellow color and another is shown in blue color. So we can see that both the point cloud has been taken for the same object, but from the different angle, the position. So eventually it's getting closed and getting merged together and giving the complete 3D perception of the objects. So I have categorized the point cloud registration in two types. One is pairwise registration and second is multi-view registration. So pairwise registration basically focuses on only 2-point cloud registration. Conversely, multi-view registration focuses on the registration of the multiple point clouds simultaneously. There are so many algorithms has been developed for the pairwise registration. Opposite to that, there are very few algorithms which is developed for the multi-view registration. And pairwise registration doesn't give the complete 3D view of any object or the environment, while multi-view registration, it provides the complete point cloud or 3D model of any environment or the object simultaneously. Next, come to the calibration. Calibration is basically the estimation of the relative position and the orientation between the two sensors that we are trying to fuse together, or we can say that we are trying to calibrate. So calibration basically ensures that whatever the data that we are getting from the different sensors are well aligned. So these sensors could be IMU or LIDAR or RGB camera, or it could be anything. So here I have explained the calibration through a diagram. So in the first figure, we can see that there are two sensors. These are two Velodyne sensors. Both are kept at certain orientation and the position with respect to each other. So RNT are basically the rotation and translation vector. So using rotation and translation vector between the two sensors, we can have the data from the both the sensor aligned correctly. So in figure I have mentioned what are the different parameters for the calibration. There are two parameters for the calibration, that is called extrinsic parameter, which is translation vector, and the rotation parameter. So here is the example of the calibration. So there is a car. Here two sensor, which is Velodyne sensor, has been kept, or we can say installed together. So as this car is moving through some environment, it's giving the point cloud of the tree. So we can see that there are 2 point cloud of the tree. One is shown in red color, another is in blue color. So there are some drift between the 2 point cloud. We can see that it's showing some kind of gap between the 2 point cloud. But after that sensor has been calibrated well, or the output from the output from the sensor is well aligned, then we'll get the merged point cloud so that we can have the complete 3D view of the tree. So next is SLAM algorithm. SLAM is basically the updated version of ICP. It's an acronym of simultaneously localization and mapping. So it basically, mapping is basically represented by the point cloud or the 3D reconstruction map of the surrounding, or and the trajectory and the trajectory will be defined by the some positioning system. So if the SLAM algorithm is integrated with multiple sensor like RGB camera, IMU lidar, or GNSS system, then we'll have the map of the surroundings as well as the trajectory of the environment. So the quality of the final register point cloud, which includes the SLAM algorithm, will basically depends on the selection of the features which is important for the registration, then the position and the attitude information that we'll get from the IMU sensor, and the range information that we get from the lidar sensor. So in this figure, here I have shown the setup of the 2 lidar sensor and 1 IMU. So in this setup, 2 lidar has been installed and 1 IMU. So as this setup will move through the environment, that environment could be anything, we'll get the registered point cloud in the real time. So here I have explained the flow chart of the SLAM algorithm. So first we'll go to the field, we'll collect the point cloud, and we'll extract the feature. On the basis of the extracted feature, we'll register the environment, and on the basis of the register point cloud of the environment, we'll update the trajectory. Then on the basis of the updated trajectory, again we'll update the map, and then we'll see that loop is closed. Then we'll go to the same place and we'll see that the loop is closed or not. If it is not closed, if it is closed, then we'll calculate the covariance. Then we'll do the registration. On the basis of that registration, we'll update the trajectory again, and on the basis of the updated trajectory, we'll update the map. So this is the overall methodology that I'm going to follow. So first I've defined the methodology. First I've defined the mathematical equation which defines that how the two sensors, here I'm using the Velodyne sensor. So how 2 Velodyne sensors are kept with respect to each other. What could be the vertical distance between the lidar, or what could be the angle between the 2 lidar. Then the same thing I have done using the Helios simulation. So for the better visualization, now comes to the hardware part. I have installed both the lidar sensor using the parameter that I got from the Helios simulation and the mathematical equation. After that, it's very important to initialize both the sensor all together. So I have done the time synchronization. Time synchronization is basically done using robotic operating system, ROS platform. So it basically helps us in getting the frames or the point cloud in the same time, at the same timestamp. Then after that, I have collected the data set at different sites to find the calibration parameter, and that calibration parameter I found using one methodology that is basically registration. So registration works like this. So first I'll collect the data set. Then after that, there will be so many outlier and the noise. Yeah. There will be so many outlier and the noises that I'll remove through the pre-processing. Then I'll do the sampling. Then I'll find the correspondence pairs. After that, I'll do the optimization. Then finally, I'll get the register point cloud as well as the error analysis with respect to the different iteration. So this is the first result of the registration. So first I have collected the data set at 3 environments. First environment was the enclosed lab environment, which has linear or planar or orthogonal features. And second is the open built-up area, and third is the forest environment. So in the enclosed environment, we had wall, chair, and table. So this part of the point cloud, which is basically the wall, I have shown in the horizontal and vertical manner here. We can see that both the point cloud collected are well aligned. One is shown in red color, another is shown in green color. So this is the result of the RMSE error with respect to the number of iteration. We can get that. We can see that here we got the accuracy up to 0.04 centimeter, 0.04 meter, which is basically 4 centimeter. Second is the open built-up environment. Here I have highlighted the some feature which is front part of the car. So front part of the car has been scanned. Here it is shown. We can see that car point cloud is well aligned here, and this is the RMC versus iteration plot. And here we have taken the data set at forest plot and registered the point cloud. Here I have highlighted the point cloud of the tree, so we can see that this trunk part is well aligned, shown in blue and red color. And here I have the RMC error plot. So in all the plots, if we'll compare, we see that we have the good RMC least error in an area which has the good feature. That feature is basically the linear or planar feature. That's why we get the very good accuracy here. And the poor accuracy we got open built up because because of the lack of the features. So finally, I have shown here the result of Helios simulation. So what I've simulated, first I've simulated one common big hall. Then I've simulated two velodyne sensor. One velodyne sensor I've kept at the center of the hall, and another velodyne sensor I kept at a vertical distance of the 1.5 meter. So and I increase the Z value. So I've increased the vertical difference between the two sensors to see that there is any change in the coverage. So we can see that if we increase the vertical difference between the two sensors, then there won't be much effect in the coverage area. But if we increase the angle between the two velodyne sensor, then we can see that the coverage area is increasing so fastly here. So at 25 degree, we found the best coverage and the best data density, because there should be some overlap between the two point clouds so that we can do the registration. So work done so far. So initially I have done the registration at 3 places to check that what is the what is the accuracy of the point cloud, accuracy of the registered point cloud at different environmental site. Then I've done the simulation. Simulation helped in getting the initial parameter for the calibration of the 2 or more sensor. Then I've done the time synchronization. Time synchronization is done to get the frames from the different sensor at the same timestamp. Then I'm doing the calibration. So I have to refine this algorithm now. So future scope of the research is basically what we are making a setup of the 2 or more velodyne sensors. So if that setup is there, then we'll include one SLAM algorithm, so that if we are working with the setup, then we'll get the register point cloud at real time. So it can be utilized for getting the 3D perception of the environment where we are moving with the sensor setup. Then it can be if the data density is good with that setup, then we'll have then we can easily extract the morphological parameter of the forest plot, and it will be very easy. And the data collection will become very easy, and it will take very less time. And the planning of the fieldwork will also get decreased. Yeah, that's it. Thank you. Yes, sir. Okay. So you're saying that the data output is poor, so how will I tackle this? Hmm. 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 Assessment. So, okay, so, hmm. So first I'll be using one algorithm that will be so robust that if I'll walking through the forest environment, then it will have the better case because that algorithm has some pre-processing technique and the optimization technique. So pre-processing will help us in getting rid of the outliers, and the optimization will help us in getting the best parameter for the transformation matrix. And you're talking about the IMU. So till now I have studied and the whatever I've done with, between the velodyne sensor, which is lidar only. So for the IMU, I have to study further. So one I have written one conference paper, and one this calibration part will be done. So it's giving some result, but I have to refine the results. It's not giving that up to centimeter accuracy. So I have to make it up to at least 5 centimeter accuracy. Yeah. Calibration. Yes, sir. Mm. Accuracy is the like most important thing because that's why I'm doing the calibration. So first of all, I'm trying to do the registration by taking the data set at different places so that we can see that the algorithm is robust or not. If it is robust, if the algorithm will be that success, then I'll take the ground data set and then I'll do the validation. So currently, I'm just working on the calibration algorithm, which is basically a registration. Once it will be fixed, then I'll take the data set from the ground. There is no predefined target, sir. So I'm taking there is no predefined targets. Okay. Yes, sir. Not correction, just like real time slam. It will be corrected using some loop optimization techniques. Sorry, sir? Well, VLP 16. Hmm. So first of all, we have to have the very good computer. Secondly, we should have some uh, ground control point. And third, which is most important, is the algorithm. How I'm defining the algorithm, because there are so many algorithms available for the registration, but these algorithm cannot be applicable for any type of area. So mostly I have to focus on the algorithm.
Yeah, good evening all. I will be presenting on deep learning architectures for urban change detection from satellite images. Dr. Shamlal sir is my guide, who is Associate Professor at National Institute of Technology, Surathkal. Okay, so this is the outline of my presentation. First, let me introduce to the change detection and its type. For example, let us consider that the IIIT campus first image is taken in the year 2010 and second image is taken in the year 2020. So we will check what are the changes that has happened over a period of 10 years. So first, which ground area is converted into building, which building is converted into ground, and which forest area is converted into building. So analyzing this change is called as change detection. So figure 1 illustrates two different types of change detection, binary change detection and a semantic change detection. So T1 image and T2 image are given to change analysis. So this binary change detection will give the binary change map, which will tell whether the change has happened or not. So it will, white color indicates that there is a change and black color indicates that there is no change. So semantic change detection will give a semantic map, which will tell what is the actual change that has happened. In this particular example, gray color indicates ground, light green indicate trees, and dark green indicate vegetation. You can see that the ground in T1 image is converted into low vegetation in T2 image, and low vegetation in T1 image is converted into water body in T2 image. So this is from to change, and this semantic change detection is much complex compared to the binary change detection. So these are the various applications of change detection. Out of this, I have chosen this urban expansion as one application for my research work. So this particular figure shows the urbanization trend in one of the area in Bangalore, that is Agrara Belandur wetland from the year 2000 to 2013. So if you look at image A, which is captured in the year 2000, we can see that 95% of the land cover is vegetation, only 5% building. But if you look at image F, which is captured in the year 2013, around 85% of the land is built up and only 15% is vegetation. So by looking at this, we'll come to know how rapidly urbanization is happening, and this trend is continuing in most of the metropolitan cities worldwide. So what is the motivation behind this urban change detection research? So we have a problem. So presently 50% of the global population lives in cities, and this is expected to rise to 70% by 2050. So urbanization is happening at a rapid rate, necessitating the accurate urban land cover information from time to time. So there are resources like remote sensing images with high revisit frequency provide a cost-effective and comprehensive source for monitoring urban development. So these days, deep learning has become one of the most important technique for remote sensing based change detection. So we have a problem, we have a resources, there is a need to develop an accurate technique to solve the problem using the resources. Keeping this in mind, this research work focused on developing a deep learning architectures for urban change detection from satellite images. So this is the literature survey on deep learning models for binary change detection. I will not get into the details. I will just highlight the demerits of the existing models demerit. So method one, as problem is large building areas cannot be detected correctly. In method two, computation complexity is very high. In method three, poor detection of small change areas. In method four, do not predict the edges correctly. Similarly, the literature survey on semantic change detection tells that in method one, many changes cannot be identified. In method two, inconsistent classification and change problem exist. In method three, more training parameters and computation complexity time is very high. And in method four, poor in edge detection and contour extraction. So based on this related work, the research gap analysis done for this binary and semantic change detection are this. So there is a need for an accurate and efficient binary and semantic change detection method, which is still an open-ended research work. The reduction of computation complexity and training time in both semantic and binary change detection is a topic of research. And there is a perspective to improve the results in binary and semantic change detection by introducing new loss function. So based on this, the problem statement formulated is design and development of a robust deep learning architectures for urban change detection from satellite images. Based on the problem statement, two objectives are framed. They are to propose a robust deep learning model for binary and semantic change detection in urban areas from satellite images. So work done is two models have been developed, that is BCD.NET and UCD.NET for binary change detection. These two work have been published in the journals which are given here. So coming to the first model, so figure 3 shows the schematic of the first model, that is BCD.NET, which is building change detection network. So the base model used here is fully convolutional CMS difference model. This BCD.NET model contains MFE block, encoder part, decoder part, along with the attention mechanism. So input image 1 taken at time 1 and input image 2 are given to the MFE block. Output of the MFE block, that is multi-scale features, are given to the two streams of the encoder. Output of encoder is given to decoder to get the change map here. And the new block that is being introduced here is MFE block, which is shown in figure 4. So the RGB image is made to pass through 2 filters, each of size 3x3 and 5x5, where there are 10 filters in each stream. And the results are concatenated channel-wise, made to pass through an activation function to get multi-scaled feature. The main function of this multi-scale feature extraction block here is to extract features from different field of view, enabling attention to both small and large change areas. And this is the adaptive attention fusion mechanism that is being used. Channel attention module is used to enhance the global feature, and spatial attention module is used to enhance the local feature here. So the data set used here is Lewis CD and WHO change detection data sets are used. And the other parameters are batch size is 1, weighted class categorical cross entropy loss function is used, Adam optimizer, and model is trained for 30 epochs with a reduced learning rate. And the performance metrics used in case of both BCDetNet and UCDNet are accuracy, IOU, precision, recall, F1 score, and kappa coefficient. So in order to check the effectiveness of the new block that have been added, evaluation study has been carried out. So only the base model experiment is conducted with only the base model in case of both Lewis CD and WHO dataset. And then next time it is base model plus the attention module. Next it is base model plus the attention. So this is our final BCDNet model. So if we look at this particular results of the BCDNet model, this result outperform any of this, only base model or base model with the attention in case of both the Lewis CD as well as WH. So this indicates that the effectiveness of the new model that is being added here, which is the MFE block. And coming to the results, these are the results. So proposed model is compared with various benchmarks model and that are presented here. This is the result with Lewis CD dataset. These are the results with WHO change detection dataset. So if you look at the result, we can see that the proposed model outperformed almost all the benchmark models here in terms of all the metrics like recall, precision, and kappa coefficient. So these are the results of our model. And these are the visual results, predicted results, T1 image, T2 image, this is the ground truth. These are the results of the benchmark model, and this is the result of the proposed model. And we can see that there is false prediction we can find in all of this benchmark model here. Whereas our proposed model, there is no false prediction that can be seen here. So the visual results of the proposed model are almost comparable with the ground truth. So this is for Lewis CD. Same thing holds good for WHO change detection data set also. So we can see that in our proposed model, the shape of the changed area is preserved, whereas that is not happening in the other models, other benchmark models. And the computation complexity is also done. So this is the computation complexity. So FCCMA difference model has less training time, less prediction time, and less parameter. Our proposed model is second best in all these metrics in case of Lewis CD as well as in case of WHO change detection dataset. The second model that is proposed is UCDNet. UCDNet stands for Urban Change Detection Network. So the novelty that are being included in this model are in the encoder of the UCDNet, features are extracted at different level using modified residual connections. A new spatial pyramid pooling block is introduced, which extract the features at various range to give awareness about the global context, preserve the shape of the changed area, and predict the change boundaries more accurately. And an improved loss function, which is combination of weighted categorical cross entropy and modified kappa, is introduced here. So this is the architecture of the proposed UCDNet model. And the base model used here is fully convolutional CMS concatenate model. So T1 image, this is the encoder part, this is the decoder part, this is the new spatial pyramid polling block that is being introduced. So input T1 and T2 image are given to the encoder, output of the encoder are given to the NSPP block, output of NSPP is given to the decoder block to get the change map. So these are the figure 10 shows the block diagram of new spatial pyramid pooling block. It contains pooling block followed by global pooling, and the details of the pooling block and global pooling are given in figure 10 and 11. So this global pooling gives awareness about the global information, which reduces the degradation problem in this change detection. Data set used is Onera satellite change detection data set, which is a multispectral data, and 13 bands are present here, and the other training setup are given here. So model is trained for 30 epochs with batch size 1, and model is trained for 5 times, and average of the results are presented in this. So as I told, the loss function is modified. It is a combination of weighted categorical cross entropy and modified kappa, and the equation related to the loss function are presented here. So again, to check the effectiveness of the new loss function and the new block, ablation study is being carried out. So in case of this the loss function effectiveness is carried out using this fully convolutional CMS concatenate model. So the model was trained using only kappa loss, only modified kappa loss, and only WCCE loss, and model was trained with combination of all these. So when the model was trained using combination of all this, results in terms of F1 score and kappa coefficients are very good. So this shows the effectiveness of the new loss function. And coming to this model, base model is FC-CMS. Experiment was conducted with only FC-CMA, and intermediate model 1, which is combination CMA and residual connections. Intermediate model 2 is combination of FC-CMA and NSPP block, and proposed UCD net, it is combination of all the three. So even in this case, we can see that proposed UCD net model, which is combination of all three, give good result, either compared to base model or intermediate model 1 and 2 in terms of all the performance metrics that are listed here. So these are the comparison, our model compared with the benchmark model, and these are the results we have got. And except this recall metric, all other metrics like precision, F1 score, kappa coefficient, and Jacquard index are improved significantly in case of UCD net. So threefold cross validation is also conducted, and even in case of threefold cross validation, the results remains the same. This shows that our model is, irrespective of the data set, model performs better. And these are the prediction results. So this is the ground truth results of our predicted model. These are the benchmark models. And you can see that the in case of our proposed model, the shape of the changed area is preserved properly, where that is not the case in case of the other benchmark model. And these results are comparable with the ground truth results. And coming to computation complexity, our FC and PP has got less training time and prediction. Our model is the second best in terms of all the three in this case. So I want to conclude telling that change detection from satellite image has become an inevitable process for characterizing and monitoring urban growth patterns. So two deep learning architecture, BCDetNet and UCDNet, are proposed for binary change detection in urban areas. And both of these models are performing well compared to the existing benchmark model. No, sir, that slide was put just to show the urbanization trend. From 2000 to 2013, that was the trend. If after 2013, it has increased more rapidly than that. Like, yes. Up to 2013, it was put. It was to show that what is how the urbanization is happening worldwide by taking example of the Bangalore city. Okay, so yes, sir. Up to 2015, traditional methods were used like principal component analysis and SVM to do this change detection. After 2015, deep learning dominated, and yes, okay. You wanted me to put that also here for comparison. Okay, yes. 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 Okay, I can tell how much improvement is there in deep learning compared to traditional methods. Okay. Okay. Okay, and definitely next time I will add I have that result of traditional methods also, but I have not included that here. Next time I will definitely add that.
Good evening to all. Today I am presenting forest type characterization using the GDI, LIDAR and allospulsar 2 dataset with the full field observation and data of the central Aravalli region. So introduction, as we know that forest is a very crucial resource for the human well-being, and also its conservation and management is needed at from the local level to global level also, because it regulate, maintain and sustain the uh, human and also a lot of biodiversity. Also, it's good understanding go to, with the field observation, and also nowadays in the technological era, remote sensing have the different type of the data set, optical data set, radar data set, lidar data set, that also provide the without reaching into the ground good observation and good data set regarding that. So till now biomass estimation is a crucial challenge, crucial for the biomass estimation is a very difficult task. Exact biomass estimation is a very difficult task for the scientist and the researcher and community, because community. So in the study, I used the active radar data set and also lidar data set for the biomass estimation and forest type characterization using the Elos Pulsar dataset with the combination of. As per know, my study area is the central Aravalli region that belongs to the 4 districts of the Rajasthan, Ajmer, some part of the Udaipur, Pali, and Rajasthan, 4 districts, and its altitudinal gradient is from the 600 meter to 1271 meter. And its total area is around 23,000 square kilometer, and it cover central part of the Aravalli actually, and have the dry deciduous forest and mixed forest, thorn forest, and basically 3 type of the forest available. And dry deciduous forest is totally dominated by the teak plants. So next, my material method, I use the 2 types of data set. First, the remote sensing data set. Second is the non-remote sensing data set. Non-remote sensing data set is mostly based on the field observation. Field observation, I have taken 2 things. First, DVH, and second is the height. And that height also compare with the GD relative height 95, and next I will show and what we can do, and also all the data process and analyze in the Google Earth engine. I will have taken the Landsat data set for and its pre-processing, cloud removal, composite and mosaic quality check. Then its band selection, and also calculate the some indices for the forest type characterization, just like NDVI and also NDBI. It means vegetation build up index, or NDWI, it means normalized difference water index. And also taking the Elos Pulsar data set, there are 2 bands, HH and HHV, and their combination HH plus HHV, and train the 2 models, SVM and second is the RF, and classify the map based on the all the band selection indices and the band of the Elos Pulsar, and classify the map again biomass density and relative height taken from the GDI and match with both of them, and lastly we conclude the forest characterized map. Next is this is the indices of our study area: NDWI, NDVI, and NDBI for the forest type characterization. And next is the support vector machine and random forest classification, and these are the mostly forest dominated in the central Aravalli region I have taken, and other classes I removed from the study area for the more precise classification, nothing else. Next, this is the accuracy assessment table where I have taken around 70 to 80 points from the as a polygon in the Google Earth engine, and classify. And in the both of them, we compare the random forest is the best suited for the forest type classification as compared to SVM, because SVM has the mostly work for the two classes classification, but RF is the multiple classes classification have the better performance as per also literature review and also shown in the image. Next is the JEDI is the for the its forest characterization based on their relative height and biomass density, and also include the previous random forest classification, and we compare them and characterize their forest type of the our study area as the broadleaf hill forest, that is also called the central hills forest. Teak mixed deciduous forest is the dry deciduous forest, and last is the thorn forest, and this is the our some uh, uh, field observation photographs, and this is a discussion and discussion conclusion. In here we can analyze the forest type characterization using machine learning approach to random forest and support vector machine, and also for the better precision I can use the optical data set of their indices and bands, some selected bands, and their most highest accuracy found in the random forest is around 89%, and their kappa coefficient around 0.82%, 82, and SVM has a accuracy around 67%. And in the last, also quantify the biomass using the JEDI dataset, and allows are used for their characterization and compare with them. Thank you. Yes, sir. During the submitted the abstract, I have not gotten the PhD. After during that, I got him. Yes, sir. Yes, sir. Sir, a lot of pixel mixed with the because of mixed forest and thrown forest, their reflectance between their scatter value between the -10 to 15, and that overlaps sometime. That's why I have taken the some indices. That indices more precise giving the for the their training set. And sorry, exactly, sir, this is the more precise data set for the forest classification. Forest classification for the LULC, but if goes into depth, that a scatter value may be sometime matched and overlapped. That's why I'm can say. Yes, sir. No, I remove the cloud cover. Yes, sir. Quality check, quality of the bands, and also, sir, full form. Yes, sir, I remove it. I removed their also outliers from that particular.
So, good evening, everyone. So, myself, Maurice Ali. I'm a journalist and scholar of IIT Kanpur and TU. Sorry? No. Uh, okay. Okay. No problem. So, I will be presenting on the I am developing the upscaling model by integrating the LiDAR on a different platform, the terrestrial one and the aerial one, for estimating the individual tree level morphology and the above ground biomass. Okay. So what's the motivation behind this study of doing this study? You can see like there are different graphs. Like first graph, we can see that before the industrialization in the 1950s, the maximum CO2 level was gone up to a higher level of 300 ppm. But just after the industrialization, that you can see a sudden rise in the CO2 level. You can also see from the last 60 years, it is generally increasing gradually. And we are just like burning the earth, or we can say like we are abusing the Mother Earth by cutting down their power, because nature has its own power to regenerate or purify its whatever we do through the anthropogenic activities. But we are cutting down it by cutting the forest and trees. You can also see from the last 60 years, it is this map you can see, it is converting into the red map, and red means danger. This is just one of the image from the last month of the Agra Taj Mahal, and you can see how much polluted is this. Like the tourists, they can't even take the selfies of this monument. This is from the last month only. So talking about the forests, these are some of the statistics. Like forests account for about the 80% of the exchange of the carbon between the terrestrial and the atmosphere. Out of the total forest biomass, 50% is from the trees. And after this 50%, 85 to 90% is the above ground biomass. So that's why we are generally focused on this above ground biomass to quantify the carbon sequestered in the atmosphere. So for answering this question, why biomass estimation is required, like for this global carbon cycle, to understand the global carbon cycle, for the forest management policies, and for the carbon trading and all these stuffs. Talking about the traditional methods, what are the traditional methods that are used for the estimating the biomass? That was the first one was the destructive one. That is harvested it, overnight and bake it. This is a simplest technique which was accurate, destructive, but very limited to a very small spatial extent, labor intensive and time consuming. Later on, they have developed some of the allometric questions in which some of the parameters like the tree height and DBH can be inputted, from which biomass can be estimated. However, these are non-destructive in nature, but relatively not much accurate as compared to the destructive one. And also, these are also limited to a very small spatial extent and only limited to only those forests on which these allometric questions are developed. Talking about the research gaps, so the traditional methods that are talking about as far as the Indian forests are concerned, we are using the traditional methods. And as far as we know about the remote sensing technology, they are using only the satellite optical data. But the main problem with the satellite optical data is the third dimension, that is the verticality, the tree height, which is a very critical parameter for estimating the biomass. So that's why we are using the LIDAR for Indian for the forest, because it gives a third dimension, which is a very critical parameter for estimating the biomass, either related to the allometric equation or either related to non-destructive nature. Globally, there is only a limited option of integrating the terrestrial and the aerial LIDAR. And as far as the global focus was concerned, these are generally focused on the homogeneous forests, which are very planted forests, like most of the European countries and Canadian countries are there. So these are the developed model was only for the homogeneous forest, but like the Indian systems, like the Indian forest has the tropical one, which are very natural forests and the heterogeneous type of forests. These are very challenging one. So I am developing the upscaling model for especially for the tropical areas of the countries. And globally also there are for measuring the plot level measurements, they are relied on the destructive techniques. And I'm developing a model that is fully non-destructive in nature. So this will be the proposed methodology to achieve this target. So first, the TLS scanning of some of the sample plots will be done for the study area. Then the reference AGB model will be generated. And this can be done by first ground filtering it, so that we can have a trees and the ground filtered. Then individual tree segmentation will be done, which will be further leaf filtered, so that we have a point cloud of the wood and leaf points only. And these wood points can be inputted into the QSM model, which are nothing but the collection of the hierarchical small sets of cylinders, which can be further converted into the volume, and volume can be converted into biomass using the conversion ratios. Then the ALS data collection of the whole study area will be collected. And by integrating that, we can upscale the the biomass that is collected with the TLS can be upscaled to the ALS data. To increase the performance, we can also include the optical data such as for the estimating the species information to incorporate it into this, and we can have the AGB of the whole area. AGB stands for above ground biomass. So by following that methodology, these are some of the objectives that can be fulfilled. Like we will develop the this is already developed. Like machine learning technique is developed for developing the leaf filtering. This has to be done like an upscale model. This will be the ultimate goal. We will develop the TLS AGB model, which will be a non-destructive one. This is a non-destructive technique for estimating the biomass at a plot level. And this will be upscaled to a broader scale by integrating the terrestrial and the aerial lidar. We can also incorporate the species information to enhance the biomass and carbon structure estimation based on the species-specific correlation issues. And based on that, we can also develop the allometric questions. And this will be a more generalized one that can be applicable to most of the forest types, especially for the tropical ones. This is just a flowchart of the methodology. I should skip it because of the time constraint. Talking about the preparation, we have already access to the 250 square kilometer aerial lidar data and the photographic data of the Haryana by the Haryana Forest Department. We have a MAU with the Haryana Forest Department. If they have give us the permission to collect the field data, and we have already started to collect the field data. We have collecting it from the last 20 to 30 days. We have also access to the terrestrial lidar data sets to various geographical locations like from the Germany, Guyana, Cameroon, Indonesia, Peru, and China. So this you can see there are variations in terms of the geolocations also. We already implemented the machine learning model for the leaf filtering. For the field data collection, we have already the required instruments and the processor to process the point cloud data. In order to have a good result, fruitful output from this project, we have a research collaboration with the different institutions. Talking about our recent advancements, we have already developed a random forest solution for the leaf filtering on the TLS data, and we have compared it with the already developed algorithms, and it is outperforming all others, either in terms of the accuracy or in terms of volume estimation, or either in terms of the what we can say density, the point cloud density. So in terms of variable of point cloud density, it is outperforming all the other algorithms. We have also given a hybrid solution for the tree volume estimation. We have taken the advantages of the meshing approach and the QSM approach, and we have integrated it. Like from this figure, you can see this is the output. This will be the original data. This is the model that is developed by the QSM approach, and this is our approach, that is the hybrid one, in which lower part is reconstructed with the meshing approach, and the upper part is reconstructed with the QSM model. And we have generally improved it. Talking about the deliverables, what are the deliverables of this project? So this is already developed. That is the leaf filtering for using the TLS. We will have a tool for the tree volume estimation. We will have a tool for upscaling the AGB estimation from TLS to ALS. This is already going on. And we are collecting the first ever TLS forest data collection in India, which will be published online and available freely to any of the interested people. Talking about the sustainable development goals, out of the 17 sustainable development goals, we are covering the 8 sustainable development goals using this project. So thank you, and I will close this PPT with the famous quote, like there is a magic machine that sucks carbon out of the air, costs very little, and builds itself. So nature has its own ways, so we should stop cutting down their power. So just save their power, save the forest, save trees, and save the planet. Thank you. Yeah, actually, it is proposed one. I have not yet used the optical data. So I will use the optical data especially for the species information, to incorporate the species information. Because in a heterogeneous forest, we have a small, what can say, clusters of the specific type of species. So if we can have the species information from about the larger area, because LiDAR cannot give the what can say band data. It has a single band data, only the infrared data. But if we use the multi-spectral data or the hyperspectral data, then it can incorporate into this model, then it will improve the accuracy that we will get finally. Yeah. Actually, yeah, actually, I have given in the appendix because of the time constraint. I have not covered that. Yeah, yeah, sure. Yeah. So this is the, like you can see, for the, especially there are different type of QSM models. If we talk about the ADQSM model, this is the mean absolute percentage deviation. So it was giving 28.74%. And on the hybrid approach, it is down to the 16.65%. So you can see for the, especially for the complex trees, this is for the buttress one. It is behind this. So it is a buttressed trees, and this is a complex tree. For the complex trees, it is generally improving. And it is covered for the data set of almost 126 trees. So, and these 126 are across different regions like Cameroon, Guyana, Indonesia, Peru, China, and Chile. Yeah, because of like a generalized approach should be available. Yeah. 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 It will when the yeah. Yeah, I'm more focusing on the simple upscale model in which you have to give just the ALS data and the output will give the biomass. Yeah. Yeah, sure.
I'm Archana. I'm in my 4th year of PhD. I'm doing my PhD under the guidance of Krishna Mohan Buddhiraju sir. I'm here to present my texture-based segmentation and classification in quantum framework. Yeah, background to this, currently remote sensing images are widely used in medical analysis, in land cover classification, in change detection and all. So my area is urban classification. So the problem here is the remote sensing by nature itself is heterogeneous. It is like, it depends on the angle of elevation, orientation, the shape, size, everything adds to the complexity. So urban classification when compared to the normal nature classification itself is more heterogeneous because the same object when viewed from different resolution, the angle changes its shape, size, right? Those spectral signatures between, like taken for example, the building and the highway both have spectrally same signatures. Then how to differentiate it? So for this motivation, we used here textures into this thing where textures introduces spatial informations. It brings in different set of features based on the neighborhood. It's a regional descriptor where with the neighborhood, the details changes, and it is very, when GLCM is used, it is statistically consistent, rotational and scale variant, captures local as well as both global features. It has very good interpretability. So now when coming to the quantum framework, provides a new set of tools for ML. It is excellent at handling and manipulating vectors and matrices, potential speed up for training, performs implicit computation in a intractably large Hilbert space through an efficient management of data inputs. Quantum advantage can be reached only when the quantum kernel cannot be classified classically. So what is quantum? Or how can a quantum data be represented? Classically, we have only two bits, that is 0 and 1. Whereas in quantum, we can represent the same data in a linear, infinitely many states as a linear combination of both 0 and 1. So basically, each bit is represented as a linear combination of 0 and 1, where probability of 0 is represented by alpha square, probability of 1 is represented by beta square. Now, when a qubit can be represented on a block sphere, and this representation happens to be there can be infinitely many represented and not just zeros and one. Now, in each qubit is represented as a 2D vector, where the first one represents the probability of being in 0, probability of being in 1. For one qubit, it is represented as a 2D column vector. When I combine one or more qubit, I can combine it as a tensor product, giving a larger dimensional tensor vector. So now, when we are classifying on a block sphere, if I use one qubit for classification, if this is my hypersphere, the points above the hypersphere belong to one class, and the point below the hypersphere represent the other class. Right? A detailed view is given here. Now, when I say each one, this can be, the whole thing can be represented on IBM's Qiskit was used. And on the Qiskit, a circuit diagram was used. I mean, in the circuit, this line indicates one qubit. When I use a qubit and I use a Hadamard gate, the qubit is put into superposition. What I mean by superposition, the ability to represent the state in both linear combination of zeros and. So once I do that, so I can represent multiple states together as amplitudes of that particular state. Now this is nothing but bringing the entanglement using C0. When I entangle, even if the qubits are geographically apart, they represent the same state. So now, given two classical inputs, I represent them as quantum states. So, given the classical data represented as quantum state is given to a quantum device, a kernel is generated, and that henceforth this classification is done classically on a classical machine. So generated kernel is represented like this. Now, to globally understand what is happening, so given the qubits, you encode using the feature map shown in the last diagram. So this is the pre-processing part, setting of your parameters and other things. And this measurement is based on this kernel, giving you the prediction results. So my problem statement was texture segmentation based binary classifier to classify different image patches. Now for this, we evaluated quantum kernel and quantum kernel against the classical kernels. So we also evaluated the effectiveness of GLCM parameters. This problem can be considered into two parts. First, classification as well as segmentation. So the data set we used was Pavia University, Indiana Pines, Salinas, AID, and Eurosat. So in my first we tried classification, multi-class classification of hyperspectral data using quantum kernels. So this work was presented at SPIE conference, Germany, 2022, where we took 3 different data sets, Pavia, Salinas, and Indiana Pines. Here we took only the 4 classes. In every data set, we took only the 4 classes, and we tried to predict the results. The results here were for linear kernel, this was the result. For polynomial, radial, and quantum, I took 5 training sets, 10 and 20 in Salinas A, 20 samples. Here for Pavia University, I took 10, 20, and 50 samples per class. And for Indiana Pines, I took 10, 20, and 50 samples using OVR, OVR method. So the results were like this. In the quantum, the domain, using quantum kernel, I got full 1 accuracy even for using 5 training samples per class, which was not the case with other kernels. Only for radial here, we have got the similar result. Otherwise, I've got a better results in using quantum kernel for all 3 cases. More, I mean, if not better, it was the same as the classical kernel. So in the next we studied what can the textures, when using texture features, can there be a better classification? So we had, in my next work, I took multi-class texture feature classification using quantum kernel and comparison with the classical kernel. Here, GLCM texture features using SVM was considered. All the experiments were tried on IBM cloud-based simulator, and this work is published in IGRSS 2023 at Pasadena. So the result here, what I did was, I took the three built-up classes like industrial, highway, and residential, where all the three classes have same spectral signature. So we took the patches, we took 40 patches of industrial, 40 patches of highway, 40 patches of residential from Eurostat dataset, and we compared, we calculated the texture features by varying the GLCM parameters and the elevation angles, and we calculated the texture features. 6 of the texture features were calculated, and then the results were generated. For D is equals to 2, we got the best accuracy in almost all cases. D is equals to 2 and D is equals to 3. For both, this was for industrial and highway, residential and highway. We have even worked on the multi-class version of this, but the results are yet to be published. So next we are currently in the working of segmentation part of my problem set, where I am using segmentation using texture features. So the same classes from AID dataset were used. Rough image was created using stitching of the scenes. So this was a ground truth. Current segmentation results obtained are this. Currently, we are in process of can we propose some new features other than GLCM, Harlick features. So we are studying, and the evaluation of that is in process. So quantum kernels, to conclude, the observations were like this. The quantum kernels are fast at training, need less number of training samples, capable of learning complex data, and they are better at prediction compared to classical kernel, resulting in a very good accuracy. So these are my publications. No, sir, this work is still in the process. Yes, sir. So when I published the paper, it was just in a process. Yeah. Yes, sir, because the quantum framework is still in its nascent stage. So we have only 5 qubits. So we can't use too many data samples. No, I have written I'm using IBM's Qiskit, this thing, simulator, and I'm writing the code in, using that, I'm writing the code in Python. Yeah. Speed, yes, sir. Currently, the simulator also takes time a bit more for the end-to-end results to come, if you take. But once the QRAM and other things are in place in quantum network, might be we... No, sir. I have not used that. No, we don't need, sir. We don't need that, sir. No. Yes, sir. There is a lot of scope in this particular. Yeah, we are doing on that. So because we had, I mean, only 5 qubits and so many. Yeah. So we tried to take almost like first we tried a couple of combination, all permutation and combinations are tried. But when publishing in the conference paper, we have taken with such. They are not free. They need to be paid and other things. So we tried to work with them. But that cost per minute also, it costs too heavy. I'll consider this. I'll consider it. IIT Bangalore under BKM sir. IIT Bombay. Yeah, Professor Durba sir. Yeah, CSR. Yeah, Krishnamohan sir and Durba sir and my yeah, and Durba sir are my supervisor. I was yes. Yeah, I've done. Yeah. Yeah, I'm Krishna and Buddha. Yeah.
Then we come to the end of the session, and I hope that everybody has enjoyed different aspects of the remote